Morning, everybody. Today we're going to start talking about Chapter 7, which is the response of first order RL and RC circuits. So first of all, in terms of a definition, an RL circuit is a circuit that contains resistors and inductors, and an RC circuit is a circuit that contains resistors and capacitors. So basically, we're not in Chapter 7 going to be looking at anything that contains both of those things. And as you recall from Chapter 6, the main difference between a capacitor and an inductor is that the capacitor opposes changes in voltage by storing energy in electric field, whereas an inductor opposes changes in current by storing energy in a magnetic field. So basically, in this chapter, we discuss RL circuits and RC circuits, and we talk about the discharge or sometimes the accumulation of energy due to an abrupt change in the DC voltage. So the first type of response we talk about is a natural response, which is basically when a circuit, either an RL or an RC circuit, is disconnected from its DC voltage, what happens to the circuit. And it's called natural because it's a natural response based on the nature of the circuit itself. And it's not dependent on external sources of excitation. So when we do that, we can reduce a circuit in a natural response to a single inductor and a single equivalent resistor, or a single capacitor and a single equivalent resistor. So this is sort of the basic model that we start with in terms of the natural response. So in first order RL and RC circuits, we can take a look. They're also called first order because they can be determined by first order differential equations, which some of them later on we're going to get into higher order differential equations. But right now we'll be talking about these kinds of circuits. So first we talk about the natural response, which is the current and voltages that exist when stored energy is released to a circuit that contains no independent sources. And that we're usually talking about when we disconnect from the source. The time constant of an RL circuit is the equivalent inductance divided by the Thevenin resistance as viewed from the terminals. And that gives us an idea of how long it takes for a certain percentage of the energy to discharge. Similarly, the time constant for an RC circuit equals the product of the equivalent capacitance and the Thevenin resistance as viewed from the terminals. And then we have, in addition to the natural response, we have a step response, which is the currents and voltages that result from abrupt changes in DC circuits. Stored energy may or may not be present at the time of the abrupt change. So a step response is a broader way of looking at this. The natural response is when we don't have an independent source. So for example, when we have disconnected from the independent source, and what happens to the stored energy in either the RL or the RC circuit, whereas the step response is a little bit broader. Any abrupt change, connection to, disconnection from, and you can also have stored energy present or not. So on our Moodle page, I've given you some steps for analysis, just to sort of simplify these problems. And when you take a look at the PowerPoints for this particular chapter, you'll notice, first of all, there are 7 sections that all sort of progressively deal with these concepts. There are 5 sets of PowerPoints, which are not organized exactly the way the chapter is organized, but all the material is complete in all 5 of the PowerPoint lectures. The next thing you'll see is I have put up the homework assignments, just one problem from each section. They tend to be quite lengthy, especially toward the end. So please give yourself sufficient time to work on these. But they all build on these ideas of the natural response and the step response. So one of the things that they do in here that I think is kind of nice is they talk a little bit about a practical perspective, and they talk about a device referred to as a pacemaker, which is basically an RC circuit. And sometimes individuals will have, so basically, our entire body is an electrical system, and there's a lot of mechanical systems involved in it as well, and some hydraulic systems, which are mechanical. But it's kind of interesting to think about the fact that the heart, which is an involuntary muscle, receives electrical impulses in order to keep beating in a certain rhythm. And sometimes individuals will have a disruption in that electrical signal, which can result in a low heart rate, which is called bradycardia, or a fast heart rate, which is called tachycardia. And so a tiny little RC circuit can be implanted into their chest to keep the rhythm at a good, healthy pace, which for human beings is about 72 beats per minute. Now, some extreme athletes will have low heart rates, but it's not really classified as bradycardia. It's just a very well-developed cardiovascular system, good VO2 capacities, and so forth. But it's just kind of interesting to think that a pacemaker, which has saved millions and billions of people's lives and extended life for many, many people, is really just an RC circuit. So it receives feedback, and it just sends a little electrical impulse to keep the heart beating in a good rhythm that will be healthy for the individual. So anyway, that's kind of the summary for chapter 7. We'll be working on lab number 5 beginning this week, and the material for chapter 7 is all available to you. I've not yet posted the material for quiz number 2, but that will be up very soon. That will cover chapters 6 and 7. And in the meantime, you know where to find me if you need me. So have a wonderful day, and we will wait for questions. Bye, guys.